The purpose of partial fraction decomposition is to take a fraction like this one with factors in the bottom and break it down into several simpler fractions that only have maybe one of these factors in it. Now, because I have two factors here that are reduced, they're not quadratics anymore, they're completely factored, I'm going to break this up into two fractions, one for each factor. And because they're reduced, and they don't have any exponents on them anywhere, the numerator is going to be just a number. And so I want to think about this as kind of like working backwards. If I was going to add these two fractions together on the right to get the one on the left, I would have to get a common denominator. And well, that is our common denominator, the x plus 1 times x minus 2. So to get that common denominator in my two fractions on the right, well, I'd have to multiply each of them by the missing factor. So my a would get multiplied by x minus 2, and so would the denominator. And the b would get multiplied by x plus 3, as well as the denominator. Now the denominators would all end up being the same, so I'm going to focus on just what would happen in the numerators. So the a would get multiplied by x minus 2, and the b by x plus 1. And so this is what my numerator would look like once I've got an LCD for the two fractions. And so that means it has to be equal to the numerator on the other side, the 3. And so this is the equation I'm dealing with. I need to find a and b, and so I'm going to go ahead and simplify this a little bit. So 3 equals a times x minus 2a plus bx plus b. Now if I look at this, I'm changing colors here, I've got two x terms and no x term on the other side. So that means these two terms have to add up to 0. They have to cancel each other out. And so I can come up with an equation from that. So a at x plus bx, or really just the a and the b, have to add up to 0 in order for it to be equal to the left side of this equation. Now I also have two constant terms right here, and those have to add up to the constant term on the left side of the equation. So I get another equation here. Negative 2a plus b has to be equal to 3. So now I have a system of equations that I need to solve. And you can do a substitution, or you can do an addition method here. I'm going to go ahead and do addition. So I'm going to take both of these and multiply. I'm going to multiply the bottom one by negative 1. And that's going to give me the following two equations. A plus b equals 0, and 2a minus b equals negative 3. And so if I just add these two together, I get 3a, the b's are gone, equals negative 3. And so while solving that, we can see that a equals negative 1. So now I've got my a, and since a and b have to add up to 0, well then negative 1 plus b equals 0, that's going to give me b equals 1. So now I can go back to my original equation now that I have a and b and actually fill those in. So if I erase those, a was negative 1 and b was 1. And now I have completely decomposed this fraction.